Good morning all. So today we will talk about pushdown automata. A pushdown automata is a way to implement a context-free grammar in a similar way we design DFA for a regular grammar. So a DFA can remember a finite amount of information, but PDA can remember an infinite amount of information. Basically, a pushdown automation is finite state machine plus a stack. It has an extra stack will be there to store the information. So it will has three components: an input tape, control unit, a stack with the infinite size. See, from regular expression to NFA and DFA, this is computational, this is synthetic, and then from context-free grammar to computational, that is pushdown automata, and it is more powerful than this one. So pushdown automata versus NFA. So this is a state control, and you have input. And in pushdown automata, we have extra field called stack, input tape, and stack. So this is stack with infinite size. Okay, so a PDA is like an NFA but with an infinite stack. So extra thing is here is a stack will be added to the pushdown automata. So it is 0, then you can count dollar 0, then 1 and 1. As the PDA is reading the input, it can push or pop symbols from the top of the stack. So how to build a PDA? Pushdown automata. So once when we remember each 0 by pushing X onto the stack. Read 0. So when we see a 1, we pop an X from the stack. Popping. So here pushing 0, popping 1. And then again popping. So we want to accept when we hit the stack button. So pop and then stop. So special marker for bottom because we need to stop from here. So in action, how the stack will be work here? See here. So first it will move to push, then the dollar symbol will come, and then you can put 0 because here read value is 0, and then X pop value is X, and then here the value is 0, and then X, and then it gives 0, and then 0, and then 1. Okay, and then 1. So likewise it will end. So one by one it will pop and then it will close. So notation for PDA, see here, push dollar, so epsilon epsilon, 0 epsilon, 1x, 1x, and this. So definitions here, a pushdown automata is Q, sigma, tau, delta, Q naught and F, where Q is the finite set of states, sigma is the input alphabet, tau is the stack alphabet, Q naught is Q is the initial state, F belongs to Q is a set of finite states, and delta is the transition function. And like equal to Q into sigma, like this, you can have a state, input and pop symbol, and state and push symbol. Example. So the language of pushdown automata is, it is a non-deterministic, multiple transitions on same pop input is allowed. So transition may do not have to push or pop. The language of PDA is the set of all strings in sigma style that can lead the PDA to an accepting state. So pushdown automata has three components: input tape, control unit, stack with infinite size. So all operations performed under DFA like this, but extra here is stack will be added. So here we can two operations are performed here in PDA, and is push and another one is pop. Push means a new symbol is added at the top. Pop means the top symbol is read and removed. So sometimes a PDA may or may not read an input symbol, but it has to read the top of the stack in every transition. So PDA terminology is related to PDA. So instantaneous description, we can call it as ID. PDA is represented by triplet. We can call it as QWS, where Q is a state, W is a consumer input, S is a stack content. So there is a turnstile notation, which is used for connecting pairs of IDs that represent one or many moves of a PDA. So the process of transition is denoted by turnstile symbol.